All right, so we'll take a look at the last couple of assignments here for week 8. I'm going to jump ahead just for a moment to the share your work. So the share your work is just like the lesson we went over. The only difference is I want you to do a spreadsheet, and I go over how to type things into the spreadsheet. And earlier in class today, I went over that, and I have another video here that goes over that. So you're gonna get to try the spreadsheet version whether you like it or not, because I think being competent on a spreadsheet is a valuable asset to you in the future. So if you still have questions about how to do this in a spreadsheet, I will be glad to go over those in just a little bit. Before that, let's take a look at the homework. And there were a couple of problems I thought were more challenging than the others. And nobody has messaged me about them, so perhaps I'm wrong. But in previous quarters, I got lots of questions on these. So let's see if I can remember which ones they were. They were near the end. I think it was like 5 or 6. No, not that one. This one right here. So there's a bunch of big numbers here that kind of freaked people out. And let's blow that up a little bit. So this is question number 6 in the homework. And hopefully I'm sharing the right screen. Can you all see question number 6? Yes, okay, cool. I'm really worried I'm not sharing the right screen. So we're given this formula up here. It says F equals this big G. Now it's different than the big G we talked about for the braking distance, where the big G was the road grade. This G is this gravitational constant that acts between big bodies like Earth and the moon, for example, or Earth and the sun, and how they attract each other. We also need to know the mass of each body that we're talking about. So how much material is in the Earth, how much material is in the moon. Mass is different than weight, but it's related. And then R is the distance between the two objects. And so we're just given a whole bunch of information to fill in that formula. So I'm just going to go over how to fill in that formula. And then we always want to double check when we have formulas that involve units that we're plugging in the right kind of units. That if it says meters, we use meters, not kilometers, for example. So we'll have to pay attention to that. So I'm going to copy this into my notebook so we can write some stuff down. New page, here we go. All right. So this is what's called Newton's law of gravitation. If you've taken a physics class, you might have seen it in there. If you haven't, then we get to see it now. And the formula is this right here. And we're given a little bit of information up above. So R is the number of meters the two things are apart. The masses need to be given in kilograms. So in this formula, we need to plug in meters and we need to plug in kilograms. So if we're given a different unit or asked about a different unit, we have to do some conversion. So let's see, the Earth and the Moon are 348,000 kilometers apart. And okay, so that looks like versus meters. Oh, so we have a conversion, meters versus kilometers. So we'll have to figure that out. Mass of the moon is, whoa, that's a lot of kilograms. And then the mass of the Earth is a lot of kilograms. So I might use scientific notation here, like they give up in the top so that I don't miss any zeros. So we have a few different ways we can plug this in. So let's make sure we have stuff right. Let's say, since the Earth and the Moon are about 348,000 kilometers, let's deal with that. So R equals 384,123 kilometers, kilometers, however you want to say it. However, we need to give that as meters up there. And sorry, I made a mess of that. R has to be in meters. So maybe you remember from a past life in math that kilo means 1,000. So I can replace the K in kilo with a 1,000 M because K means 1,000. And so if I do that, then I'm going to get that 384,000 times 1,000, which is going to put another 3 zeros on there. So 3, 8, 4, 1, 2, 3, 1, 2, 3. And I think I have the right number of zeros. Okay, so now I have that measurement in meters, which the formula wanted. So we've got to make sure we read the fine print. That always gets me if I don't read the fine print, because sometimes I don't. All right, so then we have M1 and M2. It doesn't matter the order we multiply. So since we're given the moon first, we can say that that's M1. So let's say M1 equals that number right there. So either we keep all of those or we put it in scientific notation. So I'm going to aim for scientific notation. I'll do it both ways just for fun. So I have to count the number of places I need to get a decimal right here. Scientific notation has to be a digit, decimal point, any other digits on the other side. There can only be one number to the left of the decimal point. So I'd have to write that as 7.348 if I wanted to use scientific notation, times 10 to the power, and then I have to figure out how many places go from here to there. So 3, 6, 9, 12, 15, 18, 21, 22. I'm counting 22 places. Double check, that's 1, 2, 3, 4, 5, 6, 7 groups of 3, that's 21. One more place makes 22. So I could say the moon's mass is that many in scientific notation, kilograms. Or I could, when I plug it into the formula, I could just use those numbers. M2 would be the mass of the Earth. And if I wanted to write that in scientific notation, it would have to be 5.9722, because in scientific notation, you can have only one non-zero digit to the left of the decimal point. And then we have to figure out how many places to get the decimal from the beginning here to this new spot. So how many groups of 3 do I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24, so this would be times 10 to the power 24 kilograms in scientific notation. Now, whether I have those in scientific notation or not, I can plug them into the formula. So the scientific notation version of this formula would be F equals, and on a calculator with scientific notation, parentheses is a good thing to use. So G, the big G, would be parentheses 6.674 times 10 to the power negative 11, and then times this fraction. So I'm going to do another parentheses for the next number. My M1 would be the moon, 7.348 times 10 to the 22nd. And I'm quickly running out of room. Let me slide this over on my paper. Ooh, no, I want everything there. Mess that up. Try again. There we go. All right, close my parentheses. And then two variables next to each other means times. I'm going to use a parentheses to be safe again. And that would be 5.9722 times 10 to the 24th. And then I want to divide those guys by parentheses, r squared. And where's my r? Right here. Oh, I didn't put that in scientific notation yet. Let's do that for fun. That would be 3.84 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Okay, 10 to the 8th meters. So 3.84 times 10 to the power 8, close parentheses, then square it. Okay, so for sure, these bottom parentheses are essential. That's important, that's important. The other ones, probably get away without them, but it's always good to be safe. So that's the way I would enter this into a calculator to make that work out. Let's double check the questions we were asked here. The size of the numbers in this question make them hard to work with. Rewrite them using scientific notation. Okay, so I was doing a good job there. So meters for the moon. So that was the, let's see, 3.84 times 10 to the power 8, I think. And again, it was warning me that I might not have been in scientific notation. Right, so pay attention to those warnings. And then double check with my notes. 3.84 times 10 to the 8. So we had to convert kilometers to meters and then count the number of places to get the decimal from where it was kind of invisibly hiding right here to the new place I want it there. And I counted 1, 2, 3, 4, 5, 6, 7, 8. 2 groups of 3 plus 2. Then, what's the next one? The moon, wrong spot. Ooh, what did I do there? I messed something up. The mass of the moon, that one was the 7.348 times 10 raised to the power 22. And the Earth came out to be 5.9722 times 10 raised to the 24th is my recollection on that one. 1, 2, 3, 4, 5, 6, 7, 8 groups of 3 to move that decimal point. 8 times 3 is 24. Cool. Once we have those, then we plug all that into a calculator. And then they talk about significant digits here. And significant digits means the number of non-zero digits that you start with. So we had a 384, that's 3 significant digits here. We had 7348, 4 significant digits there. And this one had 59, oops, too many things, 592722, that's 5 significant digits. In science, you can only use the least number of significant digits in the answer, which would be 3 significant digits here. So that means I have to round to 3 decimal points when I state the answer. What else? Give the answer in scientific notation. All right, so calculator time. And on this one, these are real numbers. We're all going to have the same problem. It's not going to be different for each of us. So let's see if we can agree on a calculator. And I'm going to type this in a different screen so I can see the numbers I need to type from my notes. All right, there we go. Hopefully we can agree on this. If you have an answer, please type it into the chat. Okay, hopefully I typed that correctly. Give me a moment to review it. That looks good. That looks good. That looks good. All right, I think I have an answer. Anybody else have one? again, for most calculators, that most important parentheses is that bottom one. That you have this value here in parentheses and then square it. All right, William and Jessica posted one. That looks correct to me. Okay, so they said it's about 1.99 times 10 to the 20th, and different calculators will display this differently. So my calculator threw this E plus 20. So at first my answer matches what William and Jessica posted. If I round that to 3 digits, I get 1.99. And on a calculator, if you get a little e or a big E, that's the calculator's version of scientific notation. It means times 10 to whatever's next. So let me copy that into my spreadsheet. Sorry, my notebook. Where is my notebook? Right there. So this is what my Google calculator gave me. Right here. And the interpretation of that E plus 20, sorry about that. Is, again, rounding to 3 digits, 99. The E means times 10, and whatever after that is the power. So positive 20, I'm just going to put a 20 there. So hopefully that came out okay on your calculator. And again, it's super important for this class that you're a master of your calculator. Spreadsheet would actually be a good way to do this, because it can package things up kind of nice for us. All right, so that was the main homework problem I wanted to go over. If anyone has some other questions that they wanted to look at, I'd be glad to take a look at that with you now.